All right, so now I'm going to move on to the last two questions I didn't go over from the review, and this is going to be the type of questions that will be on your second part of the quiz in class tomorrow. So remember, the first thing we do when we're expanding our binomials is we need to have that Pascal's triangle. So remember, this is going to be the first question that you will get. And the way that we create this is we never have a number directly under a number from the row above, and we're adding our numbers to the top right and top left in order to fill in the rest of our sequence. So for instance, we always start and end with 1. So we have 1, 1, 1, because we never write a number directly below from above. From here, we start with 1, 1, and then we add 1 and 1 to get 2, and then we end with 1, never above. We have 1, we add 1 plus 2 gives me 3, 1 plus 2 gives me 3, and then we end with 1. Start with 1, 1 plus 3 gives me 4, 3 plus 3 gives me 6, 1 plus 3 gives me 4, and then 1. And you can always, if you forget that you're starting with 1, you can always think about that this 1 is equal to 0 plus 1, and this 1 is equal to 0 plus 1 as well. So we're adding 0 and 1 to get that first number. And remember, the number of row is the digit of our second number. So there is no second number here, so this one's considered row 0, and then this is row 1, 2, 3, and 4. So the first thing we do is we identify our power of our problem, and that is the row that we will use in Pascal's triangle. So we write that row out, 1, 3, 3, 1, and then we're going to write plus signs in between. Right, now remember, when we write this formula out, we're writing it as if it's a plus b to the third power. We disregard this 2x and 1 until the end. And we start with our first variable, a, and we raise it to the power that we have, so it's a cubed. And as we move to our next term, we're subtracting 1 from our power, so it's a squared. So we're subtracting 1 from our power, so it's a to the first. We're subtracting 1 from our power, so it's a to the 0. Right, then we start, our next one goes to our second variable, b. So then we start b with b to the 0, and as we move to the next term, we add 1, so it's b to the first. As we move to our next term, we add 1, so it's b squared. And as we move to our next term, same thing, we add 1, so it is b cubed. All right, so this is our formula for expanding any binomial that's raised to the third power. You do not have to write b to the 0 and a to the 0 if you do not want to, because those are both equal to 1. But I put it there just so you can identify the pattern a little bit more. All right, then we need to go ahead and say, because this is written in terms of a and b, but our problem was written in terms of 2x plus 1. So our a was our first term in this binomial for our formula. 2x is our first term, so that means that a is equal to 2x. So everywhere I see an a here, I can just substitute a 2x. So it'll be 1 times 2x to the third power plus 3 times 2x squared plus 3 times 2x. Right? And then our second term was b, and our second term here is plus 1. So that means that b is equal to 1. So everywhere I see a b, which b to the 0 I don't have to write, here we have times 1. Here we have times 1 squared, and here we have plus 1 times 1 cubed, right? Now this is everything substituted in for the formula that we generated. Now we just go ahead and do all the math. So this 3 gets distributed to both the 2 and the x, so 2 cubed. I'm going to do all the coefficients first underneath. So 2 cubed is 8. So we're left with 8 times 1 here, so that will then give me 8x cubed. Here we have 2 squared, so that will give me 4 times 3 times 1. So 4 times 3 is 12, so that will then give me plus 12x squared. Here we're left with 2 times 3 times 1. 2 times 3 times 1 is 6, so plus 6x. And then with the last one, we're just left with 1 cubed times 1, so plus 1. So this is your final answer. All right, now on to the last question from the review. All right, so the last problem was x minus 1 to the fourth remember we're going to write the formula as if it's a plus b to the fourth power. So the first thing we do is we identify our power, 4, we go to that row, and we write that row out. So 1, 4, 6, 4, 1, and all of these get a plus sign. Regardless if there's minus or plus inside of our actual problem, since our formula we're generating is a plus b to the fourth, every single one is positive. And then this sign will change things once we substitute into what our real problem was. Right? Then remember, we start with our very first term, a, and we raise it to the power that we started with, so that's a to the fourth, and as we move to our next term, we subtract 1 from our power until we get to 0. All right, then we start with our second term, which is b, and we start with 0, and we add 1 to our power every single time we move to our next term. So we have b squared, then we have b cubed, and b to the fourth. Now, I didn't do this for the last problem, but remember, the way that you can check your work is if this is a power of 4, every single exponent, if we add all of our powers together, should add up to 4. And 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, and 0 plus 4 is 4. And the number of terms we have, 1, 2, 3, 4, and 5 should always be 1 more than what our power is. So that's a way you can check your work. All right, so now we filled in our formula, but remember, this is our formula. We need to fill it in terms of our original problem. So the first term we said was a. Well, the first term here is b, so that means a is equal to, the first term was x. So that means a is equal to x. So we can go ahead and substitute in all of our a's for x. So it will be 1 times x to the fourth plus 4 times x cubed plus 6 times x squared plus 4 times x. And remember, we didn't have to write a to the 0, so I'm not going to write that in. Right, then our second term was our b, and our second term was -1. So that means b is equal to -1. So this is where the negative sign comes into play. We do not have to write b to the 0 because we know that that's just equal to 1. So it's -1 to the first, -1 squared, -1 cubed, and plus 1 times -1 to the fourth power. Remember, one of the things we discussed in class, I'll write it up here. Anytime we have a negative number to the odd power, that is equal to a negative number. Anytime we have a negative number to an even power, that is equal to a positive number. All right, so let's go ahead and do all of our coefficients math. So this is a 1 in front, so it's just left with 1 times 1. So that will just give me x to the fourth power. Here we're left with 4 times 1 times -1, because -1 to the first power is still negative, so that will then give me minus 4x cubed. Here we're left with 6 times 1 times +1, because a negative number to an even power, so 2 is even, is a positive number, so that will then give me plus 6x squared. Here we have 4 times 1 times -1, because it's an odd power, so that will then give me minus 4x. And then here we have an even power, so it's 1 times 1, so that will then be plus 1. All right, the way that you can check your work again is we should have one more term than our power. So we have a power of 4, where we have 1, 2, 3, 4, 5. And since we have a negative sign here, our signs will alternate. So it's positive, negative, positive, negative, positive. So we know that we did this correct. All right, that is it for this video.